Right, well, we've developed another fault. I'll show you. Hope you can hear that. Got a frame collapse. Trying to keep brightness down so I'm not burnt screen. Right, well, I've had a look at a television magazine for this TV and this chassis. It says common cause of frame collapse is that, well, you'll find this resistor R442 open circuit, and it's caused by a fault with this diode D403. So that's supposed to be 1 ohm. It's not an overload at the minute. Well, yeah, it's pretty much that's opened that. Well, it's like, yeah, that's a fusible resistor. This diode, it's a bias diode. Right, so this diode, it's D403. It's actually, it's like two SVO2. It is. It's like 2 diodes in series in a single package. And what it's doing, like I said, this is it's similar to output stage with an audio amp. And you've got this output transistor here, it's an emitter follower, and this diode is biasing it on. So you've got one diode drop to account for this base emitter drop in this transistor, and another one to account for this diode here, so that you're biasing that to be like just on. But what apparently happens is that this voltage drop across here just increases. So what will happen is this will just turn full on, or on a lot, draw a load of current, you know, get right. Because the other thing is, thermally, as a transistor gets hot, the base emitter drop gets less, which makes it turn on more, which makes it get hotter, which makes it get, you know, the base emitter drop gets smaller. And it's like it runs. It's called thermal runaway. So that's why you've got this here. So that if this starts pulling excessive current, that'll open and cut it off, and then you've got that frame collapse, which is what's happened. And that fusible resistor has blown. So now, what I'll do is I'll put a new fusible resistor in here. We'll just watch this diode and see what happens to it. I measured this in circuit before, and voltage drop across it were about 1.2 volts. That's across them 2 diodes, so there's quite low voltage drop. Let's have a look. I'll just put a fusible resistor across it and test it, and it'll probably go again, but we'll just measure it quickly and see what happens. What I've done, because I'm a bit tight, I've made a makeshift fusible resistor. It calls for an half watt 1 ohm fusible resistor. So what I've done is I've just put a couple of 1.8 ohm quarter watt metal film resistors in parallel. So that'll give me like a 0.9 ohm half watt resistor, and they'll just turn black and go open, they'll not burst into flames or out. Measure voltage across this diode. It's 1.8. That's like 3 diode drops, nearly that. There's have a bias in it. Going up 1.9. Two. The resistor's starting to smoke. I'm going to unplug it. That's pretty hot, that. Although it does run quite hot. Although transistor itself's not mega hot. Wow. That 4.7 ohm one in series with it's like insanely hot. These resistors, not resistors, these diodes, I ain't got any, and I've had a quick look, can't get them anymore, they don't make them. So what I'm going to have to do is manufacture a substitute, like get a couple of diodes and wire them in series and put them in there and hope that hope it works. So that, when I first measured it before it started playing up, it were about 1.2 summit volts across it. So I'm going to try and I'll have a look through my diodes and see what I've got that's got quite a low voltage drop, and then I'll give that a go, see how we get on.